You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we introduce the broad categories of computing devices that you're likely to encounter in personal, academic, and professional settings. These devices form the visible layer of the IT world, from the desktops you see at work to the smartwatches you wear every day. Each one plays a role in how we access, process, and store information. Whether fixed or mobile, consumer-focused or enterprise-grade, every device shares a common architecture and contributes to the larger digital ecosystem. Understanding device types is part of Domain 2 in the ITF Plus exam. You may be asked to identify which device fits a certain task, match a user to a specific form factor, or differentiate between general purpose and specialized hardware. These questions test your ability to recognize and classify computing hardware by purpose and environment. This episode lays the foundation for those questions and prepares you for more detailed episodes focused on specific categories. A computing device is any system that accepts input, processes that input using internal logic, and produces output. Most devices also include some form of storage, making them complete systems capable of handling digital tasks. This includes traditional computers like desktops and laptops, but also embedded systems, network appliances, and wearable electronics. If a device uses software and hardware to manipulate data, it qualifies as a computing device under this definition. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Desktops and workstations are the most familiar category. These are stationary systems that offer high performance, ample connectivity, and upgradable components. Workstations are specialized versions of desktops designed for tasks like 3D rendering, data analysis, or complex simulations. Both desktops and workstations are commonly used in office settings, engineering labs, and creative studios. Their large form factors allow better cooling and component flexibility. Laptops and notebooks are portable alternatives to desktops. They include built-in displays, keyboards, touchpads, and batteries, allowing them to be used away from a fixed power source. Laptops offer a balance between power and mobility, and they're common in education, remote work, and field service roles. While they may not offer the same upgradability as desktops, they're versatile enough for most general-purpose tasks. Tablets and e-readers are touchscreen-based computing devices that prioritize portability and ease of use. Tablets can run full operating systems or mobile versions, and they often include Bluetooth keyboards and stylus input. E-readers focus on digital book consumption, with optimized displays for text readability. These devices are ideal for casual browsing, media consumption, and light productivity tasks. Their battery life and form factor make them appealing for travel and education. Smartphones are the most widely used computing devices in the world. While originally designed for communication, they now function as full computing platforms. Smartphones run apps, browse the web, take photos, play games, and handle productivity tasks. Most include sensors, GPS, and internet connectivity. With powerful CPUs and high-resolution screens, they rival traditional computers in functionality, especially for everyday users. Servers and server appliances are computing devices designed to provide services to other systems. These include file sharing, email hosting, database access, and application delivery. Servers can range from tower units in small offices to rack-mounted systems in data centers. Unlike user-facing devices, servers often operate without direct human interaction, and they are optimized for uptime, resource allocation, and remote management. Gaming consoles are specialized computers built for entertainment. They include CPUs, GPUs, memory, and storage, just like traditional systems, but are optimized for graphics performance and game compatibility. Consoles run proprietary operating systems and use specialized input devices like game controllers. In addition to gaming, many now support media playback, streaming services, and internet access, making them multifunctional home entertainment hubs. Smart TVs and streaming boxes represent the convergence of computing and media. These devices run embedded operating systems and connect to the internet to deliver on-demand video and apps. Smart TVs combine a display with internal computing hardware, while streaming boxes like Roku or Apple TV are standalone devices connected to traditional televisions. Both allow users to access cloud-based content and control their viewing experience interactively. Home assistants and embedded voice devices are increasingly common in residential environments. Examples include smart speakers like Amazon Echo or Google Nest. These systems are voice-activated and connect to the internet to perform tasks like setting alarms, playing music, providing weather updates, or controlling smart home equipment. They are embedded computing systems with microphones, network interfaces, and basic CPUs optimized for voice recognition and cloud interaction. Point-of-sale systems, or POS systems, are specialized computing devices used in retail and hospitality settings to complete sales transactions. These systems typically include a touchscreen interface, cash drawer, barcode scanner, card reader, and receipt printer. A point-of-sale system connects to inventory databases and sales software, allowing for real-time updates and accurate transaction tracking. Their design prioritizes reliability, ease of use, and integration with payment and inventory systems. Kiosks and public terminals are standalone computing devices built for limited-purpose, self-service functions. You'll often find these devices in airports for check-in, malls for information lookup, and hospitals for appointment management. They're enclosed in durable casings to withstand public use and typically include touchscreens, card readers, or printers. Kiosks are configured with restricted access and limited functionality, allowing users to perform only predefined tasks. Thin clients are lightweight computing devices designed to rely on central servers for most of their functionality. They include just enough hardware to run a user interface and establish a remote connection to a server-based environment. In enterprise settings, thin clients are used to reduce cost, improve security, and simplify management. Since they perform little or no local processing, they are ideal for cloud-based systems or environments using virtual desktop infrastructure. Embedded systems are computers built into other machines or appliances, performing specialized tasks. Examples include the microcontroller in a microwave, the control unit in a thermostat, or the onboard computer in a vehicle. These systems do not typically run general-purpose operating systems and are often non-configurable by users. Their firmware is written for a single purpose, and they perform that task reliably, often without the user realizing a computer is involved. Wearable computing devices include smartwatches, fitness bands, and medical monitoring tools. These devices track biometrics like heart rate, sleep cycles, or physical activity. Wearables typically connect to smartphones or cloud services via Bluetooth or Wi-Fi. Their small size and battery constraints make them highly efficient, though limited in processing power. The data collected by wearables often feeds into health apps, productivity tools, or enterprise wellness platforms. Robotic systems and industrial automation controllers are computing devices found in manufacturing, warehousing, and logistics. These devices receive input from sensors and execute instructions to move arms, conveyors, or tools with precision. They are programmed using specialized languages or logic blocks and may run proprietary firmware. While they don't resemble traditional computers, they perform high-volume, real-time processing tasks that are essential to modern industry operations. Form factor and portability are key characteristics that differentiate computing devices. A device's form factor ranges from handheld smartphones to rack-mounted servers, with variations like tablets, laptops, and towers in between. Portability involves trade-offs in battery life, screen size, and performance. For example, desktops are powerful but immobile, while tablets are light and flexible but less capable for complex tasks. Matching form factor to use case is a basic skill for IT professionals. The ITF Plus exam may include questions that ask you to identify a device based on its description or match a computing device to its environment. You might see questions that describe a scenario, like a user needing to run cloud apps on a limited budget and need to choose between a desktop, thin client, or tablet. Other questions may ask you to distinguish between a kiosk and a point-of-sale system. Being able to classify devices by purpose and function is a tested skill. Knowing the range of computing device types helps with more than just passing the exam. It prepares you for practical work. Troubleshooting, selecting hardware, and recommending solutions all rely on knowing what devices exist and what they're designed to do. As IT professionals support users across homes, offices, and public spaces, the ability to quickly recognize and understand devices becomes essential. This knowledge builds confidence and makes problem-solving more efficient. To summarize, computing devices span a wide spectrum, from powerful desktops and servers to specialized devices like wearables and automation controllers. All follow the same core computing principles: input, processing, output, and storage, though each is designed for a specific environment or task. By understanding the characteristics and purposes of these devices, you build IT fluency, improve your troubleshooting accuracy, and prepare for a wide range of ITF Plus exam questions. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.